Hello, everyone, and welcome to section 5.5 of Algebra 2. This is performing function operations. You're going to love this section. It's very straightforward after we just learned the new notation. So if you wanted to say f of x plus g of x, you know that you're going to see two different functions and you're going to add them together. This would not surprise you in any way. All you're learning today is that there's another way to write that. And you guys should like this because it's a little faster. F plus g of x. Now be careful. This is not multiplication. You're not multiplying by x. Not multiplication. That's the only place that people ever go wrong. This is still of x. So people do this so that instead of writing it out separately, they can write it together. And as you can see, they can do it for subtraction. F of x minus g of x is all they mean when you see f minus g of x. Remember, this is always of. F times g of x, or you could write it separate. And then f divided by g of x. And they've given you a few examples there so that you can see. But you're going to do all of these on your own. If we were in class, I would be done teaching for the day. The answers are on the last page, both of this video and of your notes. Literally, I normally let the class do it on their own, and that's why I provide the answers. But of course, I am going to work them out for you so that if you get stuck anywhere and you don't get the answer, you can go back and watch this video. So we're going to find f of x f of plus g of x and f minus g of x. So f plus g of x will be negative 1/2 cube root of x plus 9/2 cube root of x. That's going to give me 8/2 cube root of x, which is just 4 cube roots of x. And that's my answer. Then, as a second step, it says evaluate f plus g for the given value. So you always need to have two answers. F plus g of x is equal to this. And now watch the notation change. F plus g of negative 1,000. Let's let somebody know that you're going to plug negative 1,000 in. You could plug it in separately and then add them together. But since we've already gone through the trouble of adding them together, we can use that. 4 cube roots of negative 1,000. And this is negative 10. So my answer is negative 40. Next one, f minus g of x is negative 1/2 cube root of x minus 9/2 cube root of x. And that gives us negative 10/2, which is negative 5 cube roots of x. That's my first answer. And then now they ask us for f minus g of negative 1,000. So I do negative 5 cube roots of negative 1,000. And this time this negative 10 times this negative 5 is going to make positive 50. So if that made sense, don't just watch these. You should try as many as you can on your own. F plus g of x is equal to negative x squared minus 3x plus 8 plus 6x minus 3x squared. I collect my like terms and I put it in descending order at the same time. That's my first answer. And then f plus g of negative 1. Negative 1 squared is positive 1, so negative 4. Negative 1 times 3 is negative 3, plus 8 gives me positive 1. The second one for number 2, f minus g of x. course, we've talked about this before, distributing the negative. That's where you're going to go wrong if you go wrong. So I have negative x squared minus 3x plus 8 minus 6x and then plus 3x squared, because it is minus the entire 6x minus 3x squared. So you have to distribute that negative. Now when I collect like terms, I get 2x squared minus 9x, still plus 8. And now I'm specifically going to find f minus g of negative 1. Negative 1 squared is positive 1 times 2. Negative 9 times negative 1 is positive 9. And plus 8 gives me 19. Guess I should be checking these as I go. Great. So before I move on, they do want to know the domain of each. So for f plus g of x, the domain is all real numbers. Because with cube roots, remember what their graph looks like? Their graph looks like this. It covers the entire x-axis. There's no number that you can't take the cube root of. Whether it's positive or negative, you're going to get an answer. And the same is true for this one. What shape is this? This is your basic parabola. And then this one's an upward parabola. But both of them, again, for a parabola, the domain is all real numbers. Number 3, f plus g of x means 4x cubed plus 12 plus 2x squared minus 3x cubed plus 9. I collect like terms and get x cubed plus 2x squared plus 21. That is a cubic function, and its domain is all real numbers. And then I'm specifically going to do f plus g of 2. Really, this math, the most important thing to me is that you understand this notation. There's definitely going to be someone in the room that's not paying attention, and they're going to add f and g, and then they're going to multiply by 2. It's not what it means. It means of 2. It means that you plug it in. So 2 cubed is 8. 2 squared is 4 times 2 is another 8. And plus 21 gives me 37. Good. And then f minus g of x will be 4x cubed plus 12. Now you're going to have to remember to subtract each of these things. So minus 2x squared plus 3x cubed and minus 9. It's an easy place to go wrong. That gives me 7x cubed minus 2x squared plus 3. That's also a cubic function, and the domain is also all real numbers. F minus g of 2 is 2 cubed is 8 times 7 is 56. 2 times 4 is 8. Plus 3 is 59 minus 8 is 51. And the last one in this section, f plus g. I hope that you're not even actually watching me anymore. You should be able to do this on your own. 5 fourth roots of x. You'll notice I started to write it wrong. Make sure that that 4 is really small and that it's clear what you're doing. Plus negative 3 fourth roots of x minus 2 gives us 2 fourth roots of x minus 1. F plus g of 1. The fourth root of 1 is just 1, so 2 minus 1 is 1. And finally, f minus g of x would be 5/4 roots of x plus 1. Now I'm going to subtract all of this, which actually is going to turn them to addition. And that gives me 8/4 roots of x plus 3. And so f plus g of 1 is the 4th root of 1 is still just 1, which is 8 plus 3 is 11. Now this one does have a domain, besides all real numbers, that is. You can only take the fourth, the square root, the 4th root, the 6th root, any even root, you have to have a positive number underneath the radical, or else it creates an imaginary number. So our domain is going to be that x is greater than or equal to 0. You can take the 4th root of 0. So if you've joined me to watch this first one, that makes sense. They are a little bit different. I will also tell you that there's a lot to squeeze in here, so you might want to start writing way over here. But the basic concept is easy. It's f times g of x. So that's going to be negative x cubed times 2, and I'm actually going to switch that to be x to the 1/3. It's easier to add exponents when it's a fractional exponent than when it's in a root. And then I have x to the, I'm going to add those together. So 3 and 1/3 is just not how we usually write it in math. You may remember from elementary school, 3 times 3 plus 1. So 10/3, x to the 10/3. So that's my first answer, but then they still want you to evaluate it for the given value of x. So f times g of negative 64 is going to be negative 2. And now I do want to probably put it back as a cube root. Cube root of negative 64 to the 10th. And it's actually a ridiculously large number. I'm going to save some room for number 6 there and put it right here. Negative 2,097,152. Because the cube root of negative 64 is 4, but then you have 4 to the 10th. So it's really big. And then f divided by g of x. Again, the process itself is not hard. You're going to take negative x cubed, and you're going to divide it by 2 cube roots of x. But again, if you want to actually be able to do combine those, then I'm going to have to change this to negative x to the 9/3. I'm getting a common denominator because this is going to be x to the 1/3. Now you can leave this over 2, but remember that 1/2 and divide by 2 mean the same thing. And then this is x to the 8/3. And then I'm going to plug in my 64 f over g of x, but in this case, negative 64, is going to be negative 1/2 again. I think it's easier to plug in as a cube root, unless you're just going to do it on your calculator anyway. Then you can just do negative 64 to the 8/3. But again, the cube root of negative 64 is 4, 4 to the 8th, and then times the 1/2 is going to give you negative 32,768. So, like before, we need to talk about the domain of each one. So we have a cube root. It doesn't look like it because it's third power, but that always means cube root. So to the 1/3 means cube root. And cube root, remember, the domain is all real numbers. You have no restrictions on cube roots. And the same is true for the bottom one. Number 6, f times g of x is going to be 12x times 11x to the 1/2 which is 132 x to the, so now I have to be able to add those exponents, 1 plus 1/2. You can think of it as a whole plus a half is 1.5, but in math, for exponential notation, we always write it as a mixed number, so 3/2. So you can think of it as a whole and a half. You have 1, 2, 3/2. That's my general answer, but now they want to know specifically f times g of 4, and it might be easier for you to change this to the square root of 4. That's not square root. The square root of 4, and then to the third. Unless you're just going to plug it into your calculator here. You could do 132 times 4 to the 3/2. But I'm just trying to get you familiar with this notation. The square root of 4 is 2. 2 cubed is 8. 8 times 132 is 1,056. And then f over g of x is 12x over 11x to the 1/2. So this is technically to the 1, but I'm going to change it to a common denominator. I'm going to call it 2/2. That way I can subtract my exponents, and I get 12x to the 1/2 over 11. And now f over g of specifically 4 is equal to 12 square roots of 4 over 11. So 12 times 2 is 24 over 11. Domain. In this case, I have a square root. So the domain for both of them is that x has to be greater than or equal to 0. You can't take the root of a negative number. So just to make things a little bit more complicated, the domain of this one is, as we just said, x is greater than or equal to 0. But the domain of this one is just x is greater than 0, not equal to. Is there any chance you can see why? Because you can't have a 0 on the bottom. No 0 in the denominator. So for the top one, just saying x is greater than or equal to 0 is fine. But on the bottom one, you need to do this. And you might be thinking, oh, but after we simplified it, the x wasn't in the denominator anymore. True. But remember that somebody could do this step without actually, if I didn't ask for this first, if I just straight up went to the plug in an x and I had done f over g of 0 and I used the original functions, 12 times 0 over 11 square roots of 0. See how that would have been a problem? So unfortunately, when you're doing these, you have to look at them before they're simplified to determine the domain. So I will write that down. Determine before you simplify. And of course, we didn't have that problem on the last page because there were no denominators. So this is something new. Okay, we have 2 more of these. I'm going to start way over here again to make sure I have enough room. F times g of x is 0.25 x to the 1/3 times negative 4 x to the 3/2. Honestly, these problems are so much about your fraction skills. So I have to add 1/3 to 3/2. So how can I do that? I'm going to change them both to 6. So this is 2/6. And then this is times 3, 9/6. That's the only way you're going to be able to do it. And then you could get out your calculator, but hopefully you recognize 0.25, a quarter of a dollar, as being 1/4. So this is 1/4 times 4. They're going to cancel each other out. So you just get negative x to the 11/6. And that's my answer. Then I want to do f times g of 1. And luckily, 1 to any power is just 1. So you're all set there. And then for f over g of x is going to be 0.25, which remember is 1/4, x to the 1/3 divided by -4, x to the 3/2. But the same thing is going to happen. You're still going to have to change this to a common denominator. So 2, 6, and 9, 6. So now when I subtract, I get negative 7, 6. And this is 1/4 divided by 4. That's going to give you 1/16. It is negative, although people don't usually write the negative on the bottom, so I'm going to move it to the top. And I'll accept that answer, although we often write answers with positive exponents. Let me just check how your book did it. They wrote it, yes, with positive exponents. And they actually put the negative out in front, which is also good. I tend not to do that because if you're not looking at it carefully, you might just think it's an extension of the line. So I tend to put the negative on the top. And then again, f over g of 1 would be -1 over 16 times 1 to the 7/6. But 1 to the anything is just 1. So -1/16. Let's look at our domain. Our domain does have a denominator, so we're going to have to say x can't be 0. And we're looking at 6th roots. The 3rd root didn't matter, but this square root here does matter. So x is going to be greater than 0 for our domain for this one. For f times g of x, it never ended up in the denominator. So for this one, our domain is just going to be x is greater than or equal to 0. Having it be equal to 0 is not a problem. Last one, if you are still watching these and not trying them on your own, shame on you, of x is equal to 36 x to the 7/4 times 4x to the 1/2. In order to actually do that, you're going to have to change this to 2/4. And then all together, 4 times 36 is 144 to the 9/4. You can go ahead and leave it like that. And then when I do f times g of 16, I like to think of this as the 4th root of 16, which is 2, then 2 to the 9th times 144. But honestly, I'm going to have to get out my calculator anyway because I can't do that. And it comes out to be 73,728. And the last one, f over g of x is going to be 36 x to the 7/4 over 4x to the 1/2, which I'm immediately going to change to 2/4. And now 36 over 4 makes 9, and 7/4 over 2/4 makes 5/4. So now that it's simplified, you may think that x could be equal to 0, but remember, you must always check for that beforehand. So our domain is going to be that x has to be greater than 0, but not equal to. And for this one, because there's no denominator, x can be just greater than or equal to 0. And that comes from this 4th root there. f over g of 16 means I want to put a 16 in here. This time I will show you how to do it out because it's not too big a number. Then I have the 4th root of 16, which is 2. 2 to the 5th is 32, and 32 times 9 is 288. A lot of work on these, but hopefully you're getting the hang of it. Number 9, the graphs of the functions are shown. Which graph represents the function f plus g and which one is f minus g? So they're really just asking you the same question in a tricky way. So f plus g of x would be, if I add these two together, x squared, the 4 x's would cancel, and the 4 and the negative 5 would make minus 1. So can we find that graph? It should be an upward parabola that hasn't moved left or right, but is down 1. There you go. This one is definitely f plus g of x. And then you'll notice that sometimes they just call it f plus g. We just get lazier all the time, don't we? And then for f minus g of x, I know that that is going to be, don't forget to subtract everything. So it's x squared minus 4x minus 4x, and then plus 4 plus 5, because you have to distribute the negative. So minus g of x is going to be negative 4x plus 5. If you're going to get that wrong, it might help you to write that out. So this is also an upward parabola. It has a y-intercept at 9. So I know it's not this one, whose y-intercept is at 4. But it's going to be way up there at 9. So this is my f minus g. Okay, last one. The variable x represents the number of pages of a textbook to be printed. The cost to print can be modeled by the equation c of x, and the selling price of the textbook can be modeled by the equation p of x. Find p minus c of x. So you already know that this notation simply means p of x minus c of x. Since we are going to subtract c of x, you might want to put little negatives there so you don't make a mistake. So p minus c of x is going to be 0.05 x squared plus 20 minus 0.2 x squared minus 10, which gives us negative 0.15 x squared plus 10. But the more important question is, what does that mean? So if you have a selling price and you subtract away the cost that it took to print it, what are you left with? You're left with your profit. Okay, so this represents the profit if you have X pages. Remember, X represents the number of pages. So the last page is just the answers, but you'll notice that I was trying to squeeze one more problem on there, and this was just the only place on the paper there was room for it. You do not have to watch the video for this one, but it will be on the homework, number 25. So it was a little tricky, so I was kind of giving class time to do it, but I'll also do it for you in case you can't get it. A triangle is inscribed in a square. To inscribe means to be so big it touches the side. So this would not be considered inscribed. Write and simplify a function r in terms of x that represents the area of the shaded region. So I want r of x, and I want that to represent this area right here. So the area of the whole square minus the area of the triangle will give me that shaded region. The area of the square is side square, so x squared. And the area of a triangle is 1/2 base times height. So the base is x and the height is x. So remember, triangle, if you didn't know this, is 1/2 base times height, and squares are sides squared. So that leaves me with x squared minus 1/2 x squared. You do need a common denominator. So this is a 1 right now. So I'm going to change it to a 2 over 2. 2 halves minus 1/2 is 1/2 x squared. Or you might have just known that without a common denominator, 1 minus a half is a half. Also, the notation is important to me. So it says write and simplify a function r, so you have to label it r, in terms of x. In terms of x means there had better only be x's in your function. So hopefully that helped you get some other ones as well. And that's it for section 5.5. Have a great day.